we're not trying to create dependence. We're actually trying, in the food forest, we're trying to build plants up to the point that they can take care of themselves, give them everything they need, and it's like, okay, now to grow up and take care of yourselves. You know? If we create dependent plants on us, it takes a lot of our time, it creates a lot of energy off us. It's not what we need in the food forest. Not only that, do we create plants that are dependent on us, because the microorganisms are now born. When those microorganisms go born or dead, when a parasitic organism, cursed parasitic, nematode comes into town or fungi, the good guys billing these powers when they had a symbiotic thing going on with the plant and say, hey, stay away, Percy. Me and this, tree have, this plant have a really good thing going, He's giving me sugars, I'm feeding him, don't ruin this for me. Percy goes, oh, I want to eat it anyway, and they'll battle. So these organisms that feed the plant, that exist around the root system, are actually the external immune system for the plant too. Around the root system is the external immune system for the plant. So if you get rid of them with this water-soluble fertilization, you create an opening in which pest and disease can come in without any restrictions. If you guys are really interested in nursery practice, look up. I did studies at the Agricultural Research Institute of Australia for a year on alternative nursery practice, getting these understandings and applying them to nursery management. And I had wild success, success rates in the high 90s, things that are completely unheard of in traditional nursery methodology.
So what do we look up?
Naturalised nursery practice was the thing they eventually called it. And when I got the whole holistic system and I started approaching nurseries and saying, this is my ideas, this is what I found that works, they're like, no, it can't be. It's just no, it's unheard of, Because they really do believe that the only good organism is a dead organism, and that there's only one type of organism, which is a bad organism that will wipe out your crops, because that's all that they deal with. They never see the good guys, they only see the bad guys. And they've been told this. There's now 3 generations of current nursery understandings, teachers telling them that chemical and nutrition practice is the only way to go. But I've said, hey, what did they used to do before chemicals? And they're like, oh, it just didn't happen. But if you look up the history of nursery management, you'll find that it's actually not the case. But it's really hard to go up against, this understanding, but once you understand it, then you can work with it instead of against it. And that you save yourself a lot of pain, a lot of time, a lot of energy, and a lot of money. A lot of money. So if you've ever bought some fertilizer or something like that, you'll find that it's the biggest cost of your garden on that side thing. And you're fighting a problem. And you're seeing it as a war to be waged. And really, it's just these microorganisms I talk about, their role is actually just to maintain balance in an ecosystem. The pests, even the bad guys, are actually good guys. We'll talk about that later. But, it's about, this is how plants naturally feed themselves. This is how plants naturally defend themselves from parasitic organisms. So we just need to assist that process. How are we going to assist it? We're going to make healthy soil. Can anyone ask around? I don't know if I have anything on that sheet. No, I don't. Excellent. And don't look at your books. No cheating. There's a few things that soil needs for optimal health. And can we guess what those things are? Oxygen. Without oxygen, or oxygen-rich environment in the soil, a lot of aerobic, which is like aerobic organisms that need air to survive, not thrive in that soil. And you also find it because it doesn't have an air environment, it's usually compacted, which means it's harder for the roots to move.
And that's why earthworms come in.
Really good. Earthworms, really good too, and you might have got the next one, but it's a little bit more. The best aerator or decompactor is actually microanthropods, tiny insects and worms. And they go in there and they create these little air chambers, they split apart and create these little tunnels, and allow the air to go deep into the root system and deep into the earth. And then the microbes follow them. Or maybe the microbes, they follow the microbes. Who knows? Who laid the egg first? I don't know. Yeah, so, and microorganisms too, fungi and bacteria, they also break apart soil particles and replace them with, factory anaerobes, which is kind of spongy, kind of gluey matter, which just separates them and makes them really fluffy and moisture. If you get a healthy soil, if you pick it up and it's got these tiny little crumbs, they're called pegs. You don't really need to know that, but if you want to impress your friend. And you can see how the water penetrates through it and how it goes through it too. It shouldn't be hard in the back. You should be able to stick like a coat hanger wire into it and it shouldn't bend. A lot of ancient soils that are around Lebanon and where above the Dead Sea, they used to be all cedar forests. And you used to be able to plunge your arm up elbow deep into the soil. The topsoil was so rich and fluffy, and they chopped that all down. And now it's a desert. That doesn't mean that it can be bad again. It just means that that's what happens and that it has the potential to regenerate. But if you have this fluffy aerated soil, it allows organisms to travel through it easier. It allows roots to go deeper. So in this environment, high oxygen environments as well. It allows the water to penetrate deeper as well. So don't decompact your soil. You can put paths and stepping stones in between your vegetables, but make clear line of divide between your paths and your vegetables. You don't want to compact soil. But if your soil is full of microorganisms in life, it has the ability to fluctuate or fluff back up. So it's just about putting those organisms there. And the less that you trample on them, the more fluffy it gets, the more natural it gets. Driving on it's a big no-no. Even if you do things like use heavy machinery or earthworks, as soon as the earthworks are done, you need to start aerating the soil or putting down some mulches to microorganisms as well to regenerate that compaction.
Mulch or microorganisms?
Mulch is another thing. So mulch is the plant's insulated layer. It insulates the soil from another thing that you should be talking about. Maybe it's another concept. Maybe it prevents water from being leaked out and transferring, evaporating. It also is a food source for those microorganisms to mine, so they can feed to your plant. Decaying matter, dead plants, wood chip, anything decaying is actually food for another plant or another organism as well. And also habitat for microorganisms as well. They exist inside these particles, these bacterial anaerobes within these wood chips, and that's where they survive, breed and thrive. So their habitat as well. Pardon? Coconut husk is a really great habitat. It's amazing. You pull it apart, it's got a spongy material. Microorganisms are like something relevant to the next subject, and they also need a high oxygen environment, which coconut husk is too, and it's easily penetrated and easily broken down. And it's also got a lot of nutrients. Coconut husk has got one of the highest nutrient density or mulch or ground material that I've found. It also has the best structure and habitat, so you can't get a better mulch than coconut husk. But the thing about mulch, and this is what I want to emphasize, is that there's not one type of mulch in the forest. It's not one type of wood chip. There's lots of leaves, there's sticks, there's dead plants, there's different stages. There's a lot of diversity of mulch in a forest. And that diversity of mulch is diversity of nutrients, it's diversity of habitat, it's diversity of different soil depths, and it's diversity of life. So you need this diversity of mulch in your food forest if you want to have this diversity of life that comes out of the food forest, out of the forest as well.
So I was going to say nutrients, but I'm from the old school, so maybe, I know our soils are depleted, so how do you get those nutrients back without artificially putting them in? How do the plant needs calcium to survive? So how does it, if it's not there, how do you...
If it's a mineral, then you can actually supplement them if it's a mineral deficiency, not with gypsum or sulfur or these products. We actually found that even if they're organic, gypsum is a good one, sulfur is another one, lime, dolomite lime is another one as well. They are organic, but in the high doses and the high concentration that they're in, they actually throw out different organisms as well.
Right.
We find that gypsum affects the fungi, and it also affects the nematodes, because it kind of like, you add bicarb in water and it fluffs everything up. Kind of that effect kind of destroys the fungi outright.
So do the plants, they need nutrients, don't they?
Yeah. And also with dolomite lime, it gives protozoa, which eats bacteria and keeps them down.
Yeah.
So what we want to do is actually get mineral form of these nutrients in stone, let's say like basalt or certain crystals, high in silica. You get all those, and you do what I usually do is get a ball mill, which you make a simple one out of just a cement mixer and a couple of shot put balls, and you put them in there and you just turn on the cement mixture and it grinds it down into like a powder. And you get that stone flour and you spread that on your plants, on your soil. And the microbes will be able to mine that stone meal and actually extract those minerals and those nutrients and feed it to your plants if it's deficient in minerals. In plants I'll talk lengthily about bioaccumulators and how you can identify them just by the shape of the leaf formation and just the way that they look, and see what's actually they're trying to give to the soil, to the forest, and then you just plant them. So they're actually your food source for your plants. And they're sacrificial plants. You grow them to grow your other plants as well. And a lot of weeds are I'm getting on the tangent. But so you do need those minerals. You do need these bioaccumulators as well, and you also need the microbes to actually extract these nutrients from the decaying material, from these bioaccumulators, from these minerals, and feed them to your plants. You need those four things to give nutrient density to your plants. And if you don't have those four things, then you might have deficiencies in the system. The best method to do that is compost. Really good compost.
How do you feel about cow manure? I use a lot of cow manure.
Cow manure it's okay, but it also has a lot of those water-soluble nitrates. Anything that's like anything that can be broken down from water and becomes water soluble, even if it's natural, it kind of tends to throw things out of balance. It's okay, like in nature that happens sporadically here and there, there's poo everywhere. But it's not at a level that it throws things out of balance for too long. It supplies all the nutrients. So horse manure, cow manure is great in small doses, but you don't want to do a whole topsoil layer of cow manure like we used to in the past. You get really good crops that look great, that grow really fast, but they have too much bacteria, and all the other microbes that are out of balance. And also, they've got too much nitrogen. They have too much nitrogen, even organically. And that's why your lettuces taste bitter. It's because of the horse manure. What we actually found is that when plants actually have one of the nutrient requirements met, that through the fungal network, okay, I need to stop talking about fungi now too. Fungi is a type of microorganism. It's the dominant microorganism in the forest, and you can see fungi as like an underground web or net that goes across the surface of the entire floor of the forest, and it's microscopic. It has these little hairs. This web also, when it captures something, goes into it, draws it, breaks it down, and brings it back to the soil. So it just kind of like grabs things and brings it to the soil. And it creates symbiotic relationships with trees and feeds those nutrients as well. So the tree falls in forest, which isn't a bad thing. That's just the next stage of life. That's what Aboriginal people knew. They knew, Indigenous, sorry. People knew that death isn't a bad thing. It's just the next cycle of growth. So the tree falls in the forest. The fungi goes into that dead tree, breaks it down, decays it, strips all the nutrients out, and feeds it to the whole, all the forest and all the trees around it. Those accumulated nutrients over 100 years. And the next cycle, those next lot of trees that come up to fill the canopy of that fallen tree will be twice as nutrient dense and twice as strong because of that tree's accumulated nutrients over its lifetime. The fungi actually share nutrients between trees. So have everyone seen Avatar? Yeah. You know how they talk about how trees communicate and it's part of one of it's kind of the truth. That's what we found is that trees actually are connected through the fungal network. They exchange nutrients and they actually exchange information too. If one pest is attacking a certain tree, it communicates through the fungal network and all the other trees around it through pheromones and through the fungal network start producing toxins or start producing a pheromone that attracts the pest of those particular insects, predator. So it's really interesting.
It's amazing.
Yeah, it's amazing, isn't it? Now we've got mulch and we have oxygen and microorganisms. Water, yeah. Water is vitally important. Water is the highway for microorganisms. It's what they use to move around. If that's not there, then they can't move around, they can't make those exchanges, they can't live. They live in an oxygen and water environment. Some organisms like living in water can live without oxygen, and they're called anaerobic bacteria, anaerobic organisms. But most of the good guys, there's no good about it, but most of the beneficial ones that work with the plant, they live in aerobic environments, which is part water and part oxygen. So they need both. But if you have, what I'm trying to say is, if you have too much of a good thing, you have too much water, and if you don't drown the roots, you actually drown the organisms that feed plants as well.
And if you do hand water,
Yeah.
when's the best time? I have to late in the afternoon on dark.
On a cloudy day, I'd say.
Yeah?
Yeah, because it's just teasing the plant. The plant's getting ready to get this water. And if you actually, if you don't get as bored as easily as me, you can actually sit and watch plants. You can see on a cloudy day, when it starts getting cloudy, they start doing these things. It's like opening up.
Yeah.
They're like, oh, it's coming, it's coming, it's coming. And then that's when they expect the water. So they open up the chambers, they get ready for the water. And that's the best time to water them. And if you do it on a sunny day, or in the sunshine, one thing, it burns the leaves, affects the landscape. But also, the tree is like closing its leaves because there's so much sun, and it's pumping out of its moisture, so it's like, oh, it's a pretty dry day, I'll bunker down. And then suddenly it's water and it's like, well, I didn't see any clouds, like, where did this come from?
Yeah.
I guess I'll open up my leaves. But if you do that enough, the plant goes, no, I don't need to water myself. This magic fairy always comes on a hot day. I don't need to close myself up. I can just open myself up completely. And the water will always come because I'm blessed. And then when you go away on holiday, you're like, no, they're coming back. No, and then they succumb to